Welcome to our in-depth look at the devastating impacts of hurricanes, with a particular focus on the current situation unfolding in Louisiana. As Hurricane Francine wreaks havoc across the region, it's essential to understand not only the immediate effects, but also the broader context of hurricanes and their global impact. Hurricanes are among the most powerful and destructive forces of nature, capable of causing extensive damage and loss of life. Recently, Hurricane Francine has captured headlines with its ferocious impact on Louisiana. In this video, we'll dive deep into the science behind hurricanes, explore how Hurricane Francine fits into the larger picture of weather patterns, and understand the geographical and climatic factors influencing these colossal storms. Hurricanes, also known as tropical cyclones or typhoons in other parts of the world, are large-scale storms characterized by strong winds, heavy rain, and storm surges. They form over warm ocean waters, typically in tropical and subtropical regions, and are driven by the heat and moisture from the sea. Researchers are using advanced technology, including satellites and computer models, to track hurricanes and predict their paths with greater accuracy. This data helps improve early warning systems and enhances our understanding of hurricane dynamics. A hurricane begins as a cluster of thunderstorms over warm ocean water. As these storms draw energy from the water, they begin to rotate due to the Earth's rotation, a phenomenon known as the Coriolis effect. This rotation intensifies, and if conditions are right, it can develop into a tropical depression, then a tropical storm, and finally, a hurricane. Historically, hurricanes have caused significant damage worldwide. The Caribbean, Gulf of Mexico, and Southeast United States are particularly vulnerable due to their geographical location. Regions like Florida, Texas, and Louisiana have experienced some of the most catastrophic hurricanes in history. Hurricanes are classified into 5 categories based on their wind speed, with Category 1 being the least severe and Category 5 being the most catastrophic. The Saffir-Simpson scale is used to measure these categories, which helps in predicting the potential damage and guiding emergency responses. Hurricane Francine made landfall in Louisiana with devastating force, unleashing torrential rains, gale-force winds, and significant storm surges. The storm's impact has been severe, causing widespread flooding, property damage, and disruptions to daily life. In Louisiana, a state often vulnerable to hurricanes due to its location on the Gulf Coast, Francine's arrival has been a critical event, showcasing both the power of nature and the challenges of modern preparedness and response. The geography of Louisiana makes it particularly susceptible to hurricanes. The state's low-lying coastal regions and extensive network of rivers and wetlands can amplify the effects of storm surges and flooding. The Mississippi River and its delta, which play crucial roles in the state's ecosystem, also influence how hurricanes impact the region. To understand the significance of Hurricane Francine, it's helpful to look at the history of hurricanes and their impact on Louisiana. The state has a long history of dealing with hurricanes, with notable examples including Hurricane Katrina in 2005 and Hurricane Rita in the same year. These storms caused extensive damage, highlighting the vulnerabilities of coastal communities and the importance of effective disaster management. Hurricane Katrina, in particular, was a wake-up call for many, revealing the catastrophic potential of hurricanes and the need for improved infrastructure, emergency planning, and community resilience. The lessons learned from Katrina and other major storms have influenced how authorities respond to hurricanes today, including the response to Francine. The intensity of hurricanes is influenced by several factors, including sea surface temperatures, atmospheric conditions, and the presence of other weather systems. Warmer ocean waters provide more energy for hurricanes, potentially leading to stronger and more destructive storms. This relationship between sea temperature and hurricane intensity is a key area of research in climate science. Moreover, climate change has been linked to an increase in the frequency and intensity of extreme weather events, including hurricanes. Rising global temperatures contribute to higher sea surface temperatures, which can exacerbate the strength of hurricanes. Additionally, changes in atmospheric patterns and sea levels may further influence hurricane behavior. The impact of climate change on hurricanes is a topic of ongoing research and debate. While it's challenging to attribute any single hurricane directly to climate change, there is evidence suggesting that the changing climate is influencing hurricane patterns. For instance, warmer ocean waters can fuel more intense storms, and rising sea levels can increase the risk of flooding from storm surges. In the case of Hurricane Francine, understanding how climate change might be influencing its strength and impact is crucial. Scientists are examining data to determine whether Francine's intensity can be partly attributed to broader climatic changes. This analysis helps in forecasting future hurricanes and improving preparedness for extreme weather events. Louisiana's unique geographical features also play a significant role in how hurricanes impact the region. The state's extensive wetlands, marshes, and delta systems act as natural buffers against storm surges and flooding. However, these features are also vulnerable to damage from hurricanes, and their degradation over time can exacerbate the effects of storms. The Mississippi River Delta, for example, has been a focal point for both environmental conservation and flood management efforts. The river's flow patterns, sediment deposition, and interactions with sea levels influence how storms affect the region. Understanding these geographical dynamics is essential for developing effective strategies to mitigate hurricane impacts. In the wake of Hurricane Francine, emergency response and preparedness efforts are crucial in minimizing damage and aiding recovery. Authorities are working to provide assistance to affected communities, including evacuation plans, emergency shelters, and relief services. Effective communication and coordination are vital in ensuring that resources are deployed where they are most needed. Preparedness for hurricanes involves not only immediate response efforts, but also long-term planning and infrastructure improvements. Building resilient infrastructure, such as flood defenses and storm-resistant buildings, is essential in reducing the impact of future hurricanes. Community education and preparedness programs also play a key role in helping residents respond effectively to storms. Hurricane Francine serves as a powerful reminder of the forces of nature and the ongoing challenges posed by extreme weather events. By understanding the science behind hurricanes, the impact of climate change, and the geographical features of affected regions, we can better prepare for and respond to future storms. As we continue to learn from each hurricane, including Francine, we strive to improve our resilience and ensure the safety and well-being of communities in vulnerable areas. Thank you for joining us in exploring the powerful forces of hurricanes and the current situation in Louisiana. Stay informed, stay prepared, and support those in need as we navigate these challenging times together. Stay tuned for more updates and in-depth analyses on weather events and their impact on our world.